Today we're going to be looking at how nuclear bombs work. So before we get into talking about the bombs themselves, let's talk about a couple of key terms here. We've got nuclear fission and nuclear fusion. So with nuclear fission, this is going to be when the nucleus of an atom is split into smaller nuclei, releasing a very large amount of energy. And this is typically going to be caused whenever a neutron strikes the nucleus of that atom in order to cause it to split. And with nuclear fusion, this is when two or more atomic nuclei are combined to form one or more different atomic nuclei. And the resulting mass is less than the mass of the initial nuclei. So this is going to cause a large amount of energy to be released. Another term here is radioisotopes. So these are radioactive elements, and these are what have to be used for nuclear weapons because they are capable of undergoing fission. The unstable nature of their nuclei allows them to be split when they are struck by a neutron. And typically for nuclear weapons that undergo fission, either uranium-235 or plutonium-239 are going to be used. So there's two types of nuclear weapons. The first one here is the atomic bomb. So this is going to use the uranium-235. So when a uranium-235 nucleus absorbs or is struck by a neutron, the nucleus is going to split into two smaller nuclei, and this is going to release energy and more neutrons. So real quick, we've got a model of the atomic bomb here. So the detonator here is just going to use conventional explosives to kind of launch this piece of uranium-235 into another piece of it, and that is going to be what causes one of the atom's nucleus to be struck by one of the neutrons. So once we've gotten this process started, this is going to create a chain reaction in which the additional neutrons are then going to strike other atoms of uranium-235, and the process is going to keep continuing until all uranium atoms are used up. So the other kind of bomb we have is the hydrogen bomb. So for this one, both fission and fusion are going to be used to fuel the explosion. Hydrogen isotopes deuterium and tritium have ideally interacting nuclei for the fusion process, and typically lithium-6 deuteride is going to be used to fuel this fusion process in the bombs today. So we've got kind of a model of what all is happening here. So kind of like with the atomic bomb, step one is going to be actually fission. Just conventional explosives are going to be used up here at the top to kind of initiate the fission process. Once that fission process starts to happen, it is going to heat up the foam, which is now going to be plasma, that compresses the fissionable material. And once that process is started, then we have a very large explosion as a result, much larger than the atomic bomb.